Hi, and welcome to Mr. Garofolo's podcast. Today we're looking at applications of quadratic functions. In example 1, we used a quadratic function to model the path of a thrown baseball. We took the quadratic function, placed it in our calculator, and created a sketch of a graph from it. And the sketch looked like this. Some important features about the graph were that its y-intercept was 80, telling us that the initial height that Jack was standing at was 80 feet above the field. Notice that the value of the constant was also 80. That's always going to control your y-intercept. We also noticed that the maximum point, the vertex of this graph was 2, 144. And furthermore, one of the zeros of this function was 5, 0. And all of these features helped us answer these questions here. The maximum height of the ball was 144 feet. It took 2 seconds to reach that height, and 5 seconds for the ball to land on the field once it had been released from Jack's hand. We did not have an opportunity to find the zeros algebraically, so I'd like to go ahead and work with you on that now. So the equation was h equals negative 16 t squared plus 64t plus 80. So if we want to verify these zeros, remember the value of y at the zeros of the function is a 0. Now in this case, y was the height. So in order to solve this algebraically, we need to let h equal 0. So we have the equation 0 equals negative 16t squared plus 64 plus 80. Now we haven't factored too many trinomials that have such a large coefficient, or in this case small coefficient, in the quadratic term, or had a negative in front of them. But the same principles apply as in the past. You'll always want to look for common factors here. Now in this case, I could pull out a GCF, but pulling out a common factor other than the GCF would help make the quadratic term a positive when we're all said and done factoring. Let me explain what I mean by that. As I notice these coefficients, negative 16, 16, and 80, I could pull out 16 here. It would leave me with negative t squared plus 4t plus 5. Okay? 16 as the GCF, divide it back in to get the trinomial. But I've got an issue with this here. I've got a negative t squared. It's not that we can't factor that, but it's more of a pain. It's going to make the factoring a little bit more difficult. So instead of pulling out 16, let's pull out negative 16. The benefit to doing this is now that we'll have the quadratic term positive, since negative 16 times t squared would give negative 16t squared. We'll just have to be careful on the other terms. So negative 16 times 4 would give us negative 64. I want positive 64 here. So I'm going to have to use a negative 4. Negative 16 times negative 4 would give positive 64. And then lastly, negative 16 times negative 5 would give us the positive 80. So this seems like an insignificant step, but look at the benefit. We now have a trinomial that we're going to need to factor completely, and the value of the quadratic term is a positive. So our next step would be to break that trinomial I've highlighted into 2 binomial factors. We need a product of negative 5 and a sum of negative 4. Now, oh, by the way, I could not have used this x marks the spot trick had I had a negative t squared. The x marks the spot trick works when a equals 1. So that's another benefit to factoring out the negative there. So the numbers that are going to work would be negative 5 and positive 1. So we end up with the following. 0 equals negative 16 times t minus 5 times t minus 1. I'm going to go ahead and get rid of that negative 16 by dividing both sides by negative 16. 0 divided by negative 16 will be 0, and we're left with 0 equals t minus 5 times t minus 1. Now we'll apply the zero product property, set both factors equal to 0. So either t minus 5, I just can't seem to get that part set up the way I want to. t minus 5 equals 0, or t minus 1 equals 0. Oh, you know what? I'm looking back. My factor here, I factored a positive 1. I didn't use a positive here. So you're not learning if you're not making errors. It happens to me all the time. So look back at my work. I should have had a t plus 1 here. So no worries. Easy to fix. So our first solution will be t equals negative 1. The second solution will be t equals 5. Now remember, t represents time. Time since the ball has left Jack's hand. We cannot have a negative amount of seconds. So we would reject the negative here, and we'd take the positive. And we see that that is a match algebraically for the 0 that we got on the graph. And I'm going to skip ahead to question number 3 from your homework. A slow pitch softball is pitched to a batter. The ball follows a path where h height is given by h equals negative 2t squared plus at plus 3, where t is the time in seconds elapsed since the ball was pitched. Draw a sketch of this graph. Be sure to label your axes in units. All right. So before we even get into the graphing, there's some things that we should know right away about this graph. So look at the value of a. It's a negative coefficient. This tells us it's going to be an arch-shaped parabola. And if you think about that, that makes sense, because a softball pitcher pitching a ball, the ball will come up, reach a maximum, and then come down. We can also tell from the constant that the ball was to bend 3 feet off the ground before the pitcher pitched it, since our constant is our y-intercept. So we can go down to our graph here, which is empty, and we know that we're going to have, on our y-intercept, we're going to have 3. Now, we haven't decided on a scale here yet. Unfortunately, I can't get the graphing calculator software to work on my recorder here. So I'm going to be unable to put this in the calculator, but I'll give you a few suggestions. Okay, if you place this in your calculator and then find the vertex, it will help you determine what type of scale would be good to use on each of your axes. Remember, a y is going to be height in feet, and x is going to be time in seconds. Once you have that vertex, you can decide how far you should go up your y-axis, or the maximum number you need on your y-axis. Use your table in the calculator, help you get some other points on the graph, sketch your parabola, and then you should be able to answer all these questions. Once again, I apologize for not being able to show you this, but I tried 5 times already, and the calculator will not work with this recorder. So hopefully this was somewhat helpful. I'll see you in class.